Hello, everyone. It's 4:15, so I'm going to go ahead and get started. Welcome to Code Review Best Practices. For anyone who'd like to follow along, my slides are posted on my session page, as well as on my Twitter, which is xjmdrupal. The mask is muffling my mouth, so unfortunately I'm going to have to take it off. I was really hoping I could avoid this, but I really hope everyone tested this morning, and I would love it if you have a mask in your pocket, if you would do me a favor and put it on now, since none of you are wearing them. So as I said, Twitter, xjmdrupal, you can download a copy of the slides if it helps you to follow along and click on links and so forth. Also, just one other note before we get started. I ask that people not take photos of me for privacy reasons. Audio recordings are fine, photos of the slides are fine, just not photos of my person. This is for my privacy. If you see anyone else who has a red dot sticker on their lanyard, that means the same thing, so please respect that as well. Look for these dots when you're collating your photos after the event, and delete the photos. I've suggested to the event organizers that we try to take the leftover no photograph lanyards that DrupalCons have next year, like use their excess so that we have an easier way for people taking photos to identify from a distance someone who prefers not to have their photo taken. So hi, my name is Jess. I'm XJM on Drupal.org, and I'm a Drupal core committer. Now there are thousands of people who contribute to Drupal core, but as a core committer, I'm one of about 15 people worldwide who can actually accept changes into core's code base, making those changes a part of everyone's Drupal applications. This means that one of my primary responsibilities is reviewing other people's code. I'm also a member of the security team and a core release manager, so I actually create many of the releases that you can install on your sites each month. I've been funded full-time in my maintainer roles for over a decade, most recently by Angelina and Acquia. The role of a release manager is high pressure and time sensitive. While volunteer contributions are a vital part of our community, including on the committer team, it's unsustainable and unhealthy to expect volunteer or part-time contributors to perform the responsibilities of a full-time salaried position. Full-time funding has allowed me to respond quickly to emergencies when other committers couldn't because of the constraints of their day jobs or their time zones or their families. It helps me support critical review and support for core strategic initiatives that make Drupal worth using. Things like media, layout builder, auto updates, and so on. With funding, full-time funding, I've single-handedly created more releases than any other Drupal core maintainer in the entire history of Drupal. Including over 2/3 of the releases tagged since 8.0.0 went out. I've also been integral to nearly every core security advisory in that same time frame. When I was laid off last week, it was the second time in a year that core lost over half of its release management capacity overnight. I'm looking for a new sponsor now. Please get in touch with me if you're interested in having an exceptional reputation in the Drupal community and making it to the first page of the Drupal.org marketplace, for example. 3 of the top 5 organizations on the Drupal.org marketplace fund a core committer in at least 50% of their time. In the 7 months I was with Angelina, I was able to help them secure a platinum partner certification, and by the end of the year, they would have made it up to diamond, probably actually above Third and Grove there, who sponsor my fellow release manager, Nat Catchpole, in half his time. Now, you don't have to be a big shop to make this kind of investment either. Both Third and Grove and Angelina are really small 30-person agencies. It's a form of marketing. It'll build your brand and help you generate leads. Euro for euro, it's also probably the best investment you can make in Drupal's future. With my assistance, Angelina contributed to fixing over 170 core issues just in the short time that I was there, as well as 9 security advisories. Angelina said that furthermore, they had strangers thank and congratulate them for funding me, and that my mentorship helped excite, inspire, and improve the work of the company's other developers. I also helped them improve their code review process, which is what brings me to the session topic. So the primary goal of peer code review is to catch bugs in new or changed code before it goes into production. Peer code review also helps code health increase over time rather than declining. It's not just about the code quality, though. Software code is written by human beings for human beings, so it's important that your code review process reflect that. Put simply, peer code review is also a tool for building stronger teams. By reviewing each other's code changes as they're developed, you develop a shared understanding of your code base across the team. If done properly, it should foster open, constructive communication. It can also help create a sense of pride and shared ownership for your projects. Code review is also an excellent opportunity to mentor junior developers, some of the best onboarding there is. And finally, peer code review will help reviewers and authors alike write better code the next time, because your reviewers learn from the process too. Of course, if you want your peer code reviews to be a positive experience for your team, you need to have a positive review culture. I'm not big on emotional labor myself. I find it exhausting. It's very hard for me. But the peer code review process is one place where it really is worth putting in the extra effort to make sure that everyone involved feels safe and supported. The most important thing is that everyone in a review should treat each other as equals. Start from a place of humility. Everyone brings their own knowledge, experience, and reasoning to the table. We do peer reviews precisely because it's difficult to catch the errors in our own work. And that's true for the reviewer as well. In the years that I've had commit access to core, I've noticed that many contributors just sort of do anything I say without asking questions about it. But actually, I want to hear the author's thoughts on my feedback, especially if they disagree, because I make mistakes too. It's also important to have empathy for others involved in the review process, to consider their needs and constraints. If something seems wrong or confusing, ask a specific question about it. This will help both of you understand what's going on. If something technically works but could be improved, phrase your improvements as a suggestion. And finally, when you and others disagree about the code, encourage others to explain their perspective. Even if something definitely needs to be changed, it's helpful to have misunderstandings and additional perspectives documented on the issue for future reference. So I structure my code reviews in 3 parts to increase the chances that they'll be well received by the code author. I try to start always by thanking the author for something specific that they did well. This helps them read the review positively and shows that I'm aware of the work that's gone into the issue. If I dive straight into asking someone to change this, that, and the other thing, it might seem oppressive or like I've missed the value of their work. Next, in my comments about the specific lines or aspects of the code, I try to provide references backing up my recommendations. Even if you, as a reviewer, have seen a particular kind of problem 100 times before, the author may not have, so provide them with policy documentation, references to other code that's relevant, or the like. Providing a reference helps the code author internalize best practices a little bit at a time, and plus it also sets a good example for other reviewers to follow in the future so that everyone learns from it. Finally, after I've finished my detailed review, I close with a summary and an actionable next step for the issue. If I've given a lot of feedback, I'll highlight what I think are the most important questions or concerns. It's also always good to help contributors understand what the path to done is, and that starts with an actionable next step. Now, before I get into any more specific advice about the technical aspects of code review, I need to explain some background concepts from psychology. Of all the tools that we use to do peer code review, the most important one is actually our brains. So it's important to understand the limitations on our brains and how we can enable them to do their best work. The first concept I have to introduce is that of decision fatigue, which, simply stated, is that after we make many decisions, our ability to make additional decisions becomes worse. If you've ever come home after a long day of work and found yourself just staring into the refrigerator as if it held answers, or been completely overwhelmed by the array of choices in a US supermarket especially. This is probably what's going on. We make hundreds of decisions every day. Many of them are completely trivial. What to say or text at a given moment, what to have for breakfast. But when you make many decisions in a row, your brain gets fatigued. Symptoms of that fatigue can include feelings of exhaustion or mental fog, impulsiveness, and procrastination or avoiding making further decisions. And code review involves a lot of decisions. For every single line, we decide whether the code is right, what other side effects it might have, whether there's a better way. Another important concept is that of directed attention fatigue, or DAF. When we have to focus on a single task, like we do when we do a code review, our brains have to suppress stimuli from outside distractions. The distractions can be external, background noise, the kids, the pets, messages from coworkers. They can also be internal, random, unrelated thoughts passing through our minds, feeling hungry, worrying about the bills. Finally, distractions can also come from the code itself, code style errors, bugs in nearby code, and so forth. And this in particular is something I'll talk more about later. Unfortunately, the mechanism in our brains that allows us to push aside these distractions and focus on the task at hand gets fatigued when overused. And symptoms of that fatigue can include restlessness, irritability, and apathy, none of which are good for fostering a positive review culture. Directed attention fatigue can also cause you to miss social cues, which can make it harder to communicate empathetically with the author whose code you're reviewing. And finally, it can also cause misperceptions, confusion, impulsiveness, or poor decision-making, all of which will obviously lower the quality of your code review. It's also worth pointing out that distractions are an accessibility issue. Directed attention fatigue does affect neurotypical people, but it can also be compounded in folks with ADHD. There's been research, actually, that shows that the same mechanism in people's brains is stressed in both directed attention fatigue and in ADHD. The important difference, of course, is that directed attention fatigue is a temporary condition that you can recover from. Now, it takes time for that distraction suppression mechanism to recover after it's been stressed, which is probably one of the reasons that many folks with ADHD use a strategy of taking frequent short breaks with a timer. Overall, you should treat distractions both in the workday and in the code itself as accessibility and inclusivity concerns. And this is something that I'm trying to get better at in my own reviews as well. So with that context, let's talk about some research that's been done on how different factors can increase or decrease the effectiveness of our code development process. And references for the research backing up all the things in these slides are in the speaker notes of the slides that I tweeted earlier. The key concept to understand for this section is that of defect detection. This means of the existing potential bugs or flaws in a code change set, how many are actually identified by a given process. Higher is better because it means you found more bugs before they can become bugs. And early defect detection really is valuable. According to one of the sources I looked at, even low-impact bugs are twice as costly to fix in production, and a critical bug can be as much as 100 times more costly to fix once it's in production. For Drupal core, the equivalent of a bug being in production is probably it being in a tagged core release. And then something you might not have expected, a formal peer code review with multiple reviewers is, on average, twice as effective as automated testing for defect detection. This is actually amazing, that people simply reading the code are twice as good at finding bugs in it as computers that can run it. Of course, combining all of the above is even better. I have some slides to illustrate this that compare the effectiveness of peer code quality with different kinds of quality assurance. First off, a word about unit tests. These can catch anywhere from 15 to 50% of the bugs within their scope, or 30% on average. I didn't show the error bars on the slide because that's because unit tests were the only category up here that had such a wide range of unpredictable effectiveness. And the reason it varies so widely is because the usefulness of unit tests depends on the scope and encapsulation of the change set. Furthermore, misusing unit tests in place of integration tests can lead to a very, very high rate of false positive, especially when the code is updated. And false positives are also, well, distractions. So use them with caution. Static analysis is pretty great and can catch something like 33% of bugs in code, more actually than typical unit or regression tests. We've recently started doing static analysis on the Drupal core code base with every patch and commit, and it's been awesome. Integration tests are typically the most effective automated tests, catching 35% of potential defects. So as an aside, when in doubt, write an integration test over regression or unit tests. Now, compare all of that above with peer code review process with multiple reviewers, which will catch 60% of defects. Again, this is peer code review by itself before anyone has even run tests. Finally, for context, I've also included a statistic for the effectiveness of a large beta test with over 1,000 users. Such beta tests typically identify 75% of defects with the code on average. So just think for a second about all the time it takes to set up a beta test of that scale, to say nothing of the free work that you're getting from your beta test participants. A formal code review costs a tiny fraction of that, but still might find as much as 80% of the same stuff, even if for some reason you didn't have automated tests at all, which hopefully you do. So like I said, the statistics were about each tool by itself. But peer code review is also even more effective when combined with other strategies. If you combine design review, automated testing, QA, and peer code reviews, it can increase your defect detection rates to over 90%. That means over 90% of the possible bugs in code are found before anything makes it to production. So you should still write integration tests and still use linting and static analysis tools, and have all of that run before your peer reviewers even start to look at your code. This will reduce the number of defects in your code before it gets to the peer reviewer, which in turn will make them even more effective. In summary, peer code reviewers are your most cost-effective resource, so you should optimize for them in your development process. So how do you do that? How do you optimize for a good code review? I'm going to spend the next several sections exploring how you and your team can work together to optimize for code's reviewability. So in the graph on this slide, it compares the defect density found in a review, that's the y-axis, the vertical one, with the number of lines of code under review on the x-axis. Higher defect density is a good thing. It means that you're catching more of the bugs that already exist in a piece of code early, before the code goes into production. Lower defect density, on the other hand, is bad. These huge change sets out here with like 700 or thousands of lines of code under review didn't actually have fewer bugs. They just completely overwhelmed the reviewer to the point that the reviewer couldn't see the bugs anymore. Note that there's like a pattern of exponential decay, which means that reviewers are really good at spotting bugs in small change sets, but their effectiveness drops off rapidly as the size of the change set increases. So why does this happen? The reason is that reviewing too many lines at once can cause both decision fatigue and directed attention fatigue. So the best way to fix it is to reduce the number of lines of code under review at any one given time. Split the change set up into smaller logical pieces. Fewer lines to review means fewer decisions and fewer distractions. Based on the data, it's best to review up to 200 lines of code at a time. Now, this includes removed lines, because you need to read those lines as well to ensure the change is correct and there aren't any regressions. So you add the absolute values of the added and removed lines to get the total lines of code under review. So here's a random example from course commit history to illustrate this. This change added 113 lines and deleted 1. So that's a total of 114 lines of code under review. It's a good change set size. And in general, you should never review more than 400 lines of code at a time. Change sets even that large, 400 lines, should be reserved for simple one-to-one replacements of one thing or the like. For example, replacing a deprecated function's usages across the code base. Now here's an example of a problematic change set scoping from a different core issue. The issue was a bit much for me. I felt like physically exhausted every time I got more than halfway through it. And sure enough, I checked, and the scope of the change set was just too darn big. I'm only showing the very bottom of the diff stat here. The issue changed 94 files with 229 insertions and 201 deletions. So a total of 430 lines of code under review by adding together the 229 and the 201. Over our recommendation, and so that's part of why the review was tiring for me. Another thing that helps is to never spend more than 60 minutes doing code review at a time. Now note that 60 minutes is sort of the recommended maximum and won't work well for everyone. You might find, for example, that a shorter period like 30 minutes better works for you. And then between those 30 or 60-minute review sessions, you need to take breaks so that your brain can recover. Deal with distractions that have come up in between, but also just let your brain rest. Some folks might find that they work best with cycles of 20 minutes of code review plus a short break, followed by a long break after several cycles. Long break meaning like 30 minutes, an hour. So, speaking of distractions in code review, everyone's least favorite topic, let's talk about nitpicks. Nitpicks themselves are trivial, but how you handle them is actually a really important aspect of code review that does need to be discussed. So to me, reading code style errors is like watching a speaker who has food in their teeth. Imagine a little fleck of something green stuck right up here. It has no bearing whatsoever on what I'm saying, but you might not be able to concentrate on what I'm saying because of this little out-of-place thing in my mouth. And that's how I feel when I review a change set that has code or documentation style errors. They are minor, unimportant, and utterly distracting. I can't see your code if your white space is messed up. I can't read your inline comments if they have grammatical errors. It's a real problem. Code style errors are distractions that increase your directed attention fatigue and make the review harder on the reviewer. Trivial decisions about fixing them will also add to the decision fatigue for both the reviewer and the author. But on the other hand, nitpicky reviews that go over all of these little details are also discouraging to code authors. They've spent hours or days fixing something, and then instead of evaluating their design or appreciating their work, you get lost in the distractions of formatting issues or spelling errors. It can seem oppressive or like a lack of appreciation for the contributor's work. So how do we fix this problem? On the one hand, code style errors get in the way of effective code review, but on the other, they are the least important thing about the change set. The answer is to use automated tooling that runs every time you submit a code change before your peer reviewer looks at the issue. Instead of dozens of tiny nitpick decisions, you have one binary decision. Did it pass automated coding standards checking? The Drupal core community has now spent nearly a decade incorporated automated coding standards checking into core process and making core comply with its own coding standards. And it's kind of hard for me when I talk about this not to be melodramatic about just how valuable this has been for our community's health. It has made the core review process so much healthier and so much more focused on what actually matters. So here are some of the automated tools to use. PHP-CS, PHP-STAN, CSPEL, ESLint, and StyleLint. Core has a script that will automatically run a number of these linting checks, including the ones listed on the slide and a number of other checks on the entire code base, both as part of Drupal core's automated testing and as a pre-commit hook when core committers like myself add changes to head. You can also configure jobs for these tools using GitHub Actions, GitLab CI, Drupal CI for Drupal contributed projects, or your own continuous integration or QA process. I won't go into detail about how to set these tools up because there's much better documentation on how to do so elsewhere, but my slides are posted so you can find the list again. I strongly encourage everyone to use these tools for both contributed and client projects. In each case, Drupal core already provides a default rule set you can use for the tools to make your project compliant with Drupal core standards. And you also have the option of developing your own rule set if your project or organization mandates its own coding standards. Now, automated tooling can't catch every nitpicky type problem. I have an example here of a minor documentation fix where someone should have used the @c PHP doc tag, but didn't. They just used the word use in a sentence. Fortunately, GitLab makes it super easy to deal with this kind of thing with the insert suggestion feature. You just highlight the lines your nitpick's about. Hopefully you can see that up there on the screen way over there. And then you click the insert suggestion button, which is the leftmost one in the widget that has, it looks like it has a little caret and an underline on a piece of paper. I never knew what it was. Someone had to tell me of its existence. And so now I'm passing on the flame. So you click that button, edit the lines right there in the window, and then all that merge request author has to do to accept your suggested change is click a single button. So I have a screenshot here of, I forgot to take a picture of it before they clicked apply because there wasn't enough time, but you can see over here that they've applied that and that's now been committed to the merge request. So 1 click plus 4 characters of typing from me, 1 click from the author, no re-rolling patches for an interdiffs or any of that. So with all that background information, let's talk now about how our change sets can be optimized so that peer reviewers can do their best work. Remember, peer reviewers are the single most effective thing you have to catch issues early, safely, and cheaply. So lean into that. There's something quite important about your peer reviewers. They are your first insight into what experience someone is going to have maintaining the same code years down the line. If the reviewer can't follow your code just by reading it, chances are that's going to happen again in the future when someone else looks at it. So, optimize for readability and reviewability. It's essential that someone in the future can understand your code easily. It might even be you in a few years. You don't want to find yourself saying, yeah, did I write that? Not me. That's someone else under my name. Identity theft. It's much better to think, oh, thank you, past self. That was very clear. Thank you for documenting that for me, your future self. And I personally have actually had both experiences a lot with my own code. I'm sure many of you in the room have had at least one, and hopefully both of them as well. Now, while smaller change sets are easier to review, it's also definitely possible to take that too far. First and foremost, you shouldn't ever commit something that leaves your main branch in an unshippable, incomplete, or broken state. If you were using Drupal about a decade ago and wondered why Drupal 8's release date ended up being so much later than was initially promised, it's because of this right here. We didn't keep the code base in a shippable state, so we ended up with hundreds of unavoidable critical issues blocking Drupal 8's release. Another mistake is to try to make a diff smaller by separating out test coverage or documentation. This isn't a good idea because the tests and docs are an important part of understanding the change, and a diff that's missing them isn't optimized for reviewability. This aspect affects the immediate experience for the reviewer, the shippability of your code base, and the usefulness of your Git history. Finally, scope creep. Need another drink before I talk about this. It's just water, but you're editing a file, and you see something else that's wrong a couple lines above. So you think, why not fix that while I'm here? I know the problem, it's a simple fix. The problem with that is that it adds distractions for the reviewer and forces them to think outside the context of the original change. It also creates an ever-expanding set of changes that need to be in the issue, blurring when the issue is really done. Reviewers can make this mistake too, by the way, when reading move lines or context lines in the diff. It's very easy if a line has been moved from this file over here to that file over there to say, oh, this is wrong, it'd be better to do blah, 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 but actually all they're doing is just changing the factoring, so it's not a good point of feedback at that point. So instead of, and I make that mistake all the time myself too, by the way, so it's forgivable, just try to remove the feedback. Instead of fixing that one little thing that you find or that problem in that moved line, get in the habit of filing a separate follow-up issue for changes like that that you think need making in the future. So fix the good thing now and have a follow-up for the code you spot to be fixed later. Now, sometimes you'll get a reply from a code author that a certain bad pattern you pushed back on is used elsewhere in the code base, even if you've documented a real technical issue with the approach they're using. And they're kind of two kinds of authors here. One kind of author reads your feedback, nods, and then takes it way too far and changes every other instance of that bad pattern in the same file, or, Drupal forbid, the entire code base. Others push back on your pushback and say that no, they're going to go ahead and keep using that known bad pattern for the sake of consistency. Now, both of these things are actually the wrong approach. File a follow-up, write good new code now, and fix old bad code later. Now, you shouldn't also even fix out-of-scope things on the same line as the one you're changing. When I was first working on core in 2011, this was a mistake I personally made a lot. When I would think, oh, while we're updating this line, we might as well fix this other thing with it too. I can improve the wording, I can improve the formatting. Actually, it'll be cleaner with a ternary because we can use those now, whatever. Bad idea, don't do it. It's still scope creep and will still make your peer reviews less effective. And here's why scope is relevant even on a single line. Some kinds of changes are easily scannable if you use a word diff. Replacing all instances of a misspelled word, fixing one coding standard, or replacing a deprecated method with a new one. All these changes are easily reviewed with git diff --color-words. If you have not used it before, it will change your life, I promise. So in the diff on the slide, a change is standardizing how the word writable is spelled throughout the code base. Serious issues here, people. Let's say I thought of a better way to phrase that whole method doc block, that one sentence that says whether this is a writable storage, because that sounds a little awkward to me. It could be tempting to say, well, I'm already changing this line, so I might as well improve the rest of it. The problem with that is that it completely changes the kind of review that's needed. If the original change set is only a couple dozen instances of standardizing how writable is spelled, that's very easy for someone to scan. It'll only take a couple minutes. However, if we suddenly add in a bunch of rewritten docs, we have to use different parts of our brains. Instead of just checking the spelling, the reviewer has to think about the whole sentence. Is the new version actually an improvement? Is it grammatically correct? Are there other errors being introduced? What's more, the reviewer will now have to actually read the method to determine whether or not the documentation is accurate. Suddenly, what was a 2-minute review is going to take 20 or more, depending on how many other lines we decided we wanted to improve. The approach we should take instead is to get this simple change in, the one that fixes the spelling, and then file follow-up tasks for other improvements to happen later. Note that getDiff color words can also take a regex to specify what should count as a word break, for the purposes of the diff. I find that specifying a pattern of a single dot is very effective for reviewing things like replacing one function call with another. The example on the slide is from a recent change we made to adopt the PHP 8 stir starts with function. The original merge request lumped together adopting stir starts with, stir ends with, and stir contains. It changed like 300 lines, which meant 600 total lines of code under review because I removed line and an add one. And there were like 9 or 10 different patterns of replacements within those 600 lines. I spent like 2 hours trying to review it because the contributors who'd already done the work were very insistent that they'd already done the work. So I did my best. And after those 2 hours, it just felt like my brain was melting and I couldn't even read the screen anymore. It was really a clear sign that despite the effort that had gone into date, the issue was not well scoped. So what I did is I split the issue up myself using git add-p, split it up into 5 separate merge requests, each one with one specific pattern. So after it was split up, for the first step, for just stir starts with, used with stir pos in a position of 0, we had to review 3 things. Does the original code have a check for whether stir pos is 0? Are the comparison operator and 0 removed? And does the updated code have the correct logic? If it was originally checking that the position was not 0, then the function should be negated. Otherwise, if it was checking that the position was 0, then it should be a direct replacement for the stir pos call. So now there were only 3 decisions, and very simple ones at that had to be made for each line, rather than about a dozen. And there were only 100 lines of code under review, rather than 600. Both these things improve the reviewer's ability to give a good review and decrease the time this large change set will be stuck in the queue fighting merge conflicts. And indeed, this first step that I've been talking about was already committed, so is the second. If you want to help with the third step, it's still in the review process, and you can come see me in the contribution lounge, and you can be the one who helps us finally wrap this change set up with far fewer lines to deal with merge conflicts on. So now let's talk about the most important questions to ask during peer code review. The first thing you should do is always ask yourself if we should even be making this change in the first place. For Drupal core, there's also a corollary to that, which is that maybe this change doesn't need to be done in core, but should maybe be in contrib instead. There can be pressure in open source to merge a change because other contributors have done the work. But unfortunately, there really are changes that make the application worse, or at least less maintainable. One example of this is that we get a lot of requests for specific configurations and new options to be added to the core user interface. Sounds great, right? More features. Except that more elements in the user interface, the more elements that are exposed in the user interface, the more, in general, usability and accessibility both decline. Additional things on the page, also, are distractions. The second question is sometimes the only one an inexperienced reviewer or someone who's new to the project in question might know to ask. Does the change set completely resolve the issue without regressions? The without regressions part is important, and it means that anything that might introduce behavior changes, like a bug fix, should also be manually tested typically. The third question is whether the code quality is better after than before. Generally, a change that decreases the quality of the code base should only be made temporarily in critical situations. For example, for a core security release, we'll often add duplicated code instead of factoring it into a new API in order to reduce as much as possible the risk of any theoretical custom code breaking due to naming or subclassing issues. After the security release goes out, we file a follow-up issue to properly add a new API in a minor release. Now, note also that this sentence says better and not perfect. If something seems to be getting stuck in analysis paralysis, refocus, and ask if the current state of the proposed change is at least better than the code in head. Fourth question, does the change set meet standards for usability, accessibility, testing, and documentation? These 4 categories also correspond to what we call the Drupal core gates. For each of these categories, Drupal core has minimum requirements that must be met. Specific accessibility testing that should be done, specific test coverage and manual testing that should be included, specific types of documentation that should be added, and so on. And finally, is this the best fix we can come up with right now? This can be a harder question to answer, especially if you're newer to the application under review. But on the other hand, having multiple reviewers really increases your chances of finding optimizations and writing cleaner code. I always value working with peer reviewers who identify unnecessary API surface, for example, because a smaller API surface makes the code cleaner and easier to understand, reduces the chances of regressions being introduced, and reduces maintenance needs. Now, almost done, but I have some final tips about how to do a peer code review. This isn't from any resource anywhere. These are just XJM's random thoughts. First bit of advice, pay attention to the bigger picture of what's being changed. To really understand a change, you also need to understand the API that it affects. Read the whole method, look up callers, trace the call stack in your IDE or API documentation, or even step through it in a debugger. If you only review the code in its own context, you might miss something important. Recommendation number 2, grep, or searching the code base. After Drupal.org and Git itself, grep is the tool I use the most in my code reviews. I grep for a huge range of things, and probably at least one thing in a majority of issues I review. If I don't understand something or it looks funky to me, I check other places the same pattern is used in core with grep. If the user is only fixing one instance of something and I think the same bug might be present in other implementations as well, I grep. If I want to compare what the author is doing to other uses of the same API, I grep. Be curious and think not only about the code in front of you, but of the code base as a whole. And for my final recommendation, be curious about why something is wrong in the first place. If there's dead code, unused variables, incorrect documentation, or strange bugs, it really is worth looking into how it got to be that way. For example, if you delete dead code without understanding how it became dead code, you might be removing the last evidence of an unreported bug. If you don't understand the history or context of an issue, you might inadvertently make it worse. The best tool for learning the history of a line is gitlog-L. A lot of people know how to use git blame, but more often than not, git blame will not actually give you the information you need. A few months back, I had someone ask me to clarify a to-do comment in code related to an issue I'd never even seen before, because they saw with git blame that I was the last one who had made a commit that changed that line. Now, in reality, all I did was commit a patch that did a bulk update of all Drupal.org URLs in the code base so that they wouldn't cause redirects. If the contributor had used gitlog-L instead, it would have been clearer. And I have an example of gitlog-L for that particular situation on the slide. Now, you can't always stop there, because Git isn't great at tracking when lines are moved from another file. So sometimes you might have to check out the commit right before the last one in this list, find where the lines were moved from, and then repeat the process. But eventually, you will get to the relevant commit, and you can look up the issue that led to it and find your answer. So, as a final summary, I've tried to reduce the most important considerations for code review into 6 points that fit on one slide. First and foremost, foster a supportive review culture. Manage nitpicks with tooling like code style testing, static analysis, and merge request suggestions. Practice good scoping and optimize for reviewability. Decide as early as possible whether a change should even be made. Ensure that all your changes either maintain or improve the codebase's code quality, usability, accessibility, test coverage, and documentation. And finally, ask yourself why issues exist to begin with, look at the bigger picture, and consider better alternatives for the solution. Thank you. So I've used up all my time, so we don't really have time for Q&A because I had to replace my entire slide introducing my prior employer with a slide about why you should hire me. If you have any thoughts about that, or if you have any questions about the content of my session, I'm happy to have folks come up to the Contribution Sprint Lounge, which is in a secret, hard-to-find place on the 12th floor. Ask a friend to bring you there. You know, be sure to take a lamp and a sword. But you can ask me questions then, or tweet them to me. Thank you. We can do 5 minutes of questions, says Klausi. So does anyone have, I guess, one question? Yes.
So, very quick background. I do a lot of code reviews myself as a module maintainer.